All right, we're talking about waves. So let's do one. Here we go. Come on, get it up. Woo! Come on, let's go. Come on, come on, come on. Woo! Yeah, you guys are the best one yet. Like this is. All right. Oh, by the end of this lesson, you'll be able to identify parts of the wave, calculate the speed of the wave, and identify different types of waves. All right, definition of a wave. This is a traveling disturbance through a medium. That carries energy. Okay, a traveling disturbance through a medium that carries energy. Okay, so let's first define part of the definition. Like, what's a medium? It's kind of like in the middle, like not too hot, not too cold. This is the material through which the wave travels. Material through which the wave travels. So, traveling disturbance through a medium that carries energy. Medium is the material through which a wave travels. So an ocean wave, what would be the medium? Water. The wave that we did in here, what was the medium? You. Okay? So you're sitting here, all calm and collected, all of a sudden you're like, ah! You're disturbed. Okay? I didn't really carry energy, but you get the idea. Good with that? Okay, so here is some anatomy of a wave. You might recognize some of this from chemistry, some of this from math. Okay, the amplitude. This is the distance from the undisturbed medium, which is the red arrow here, or the red line here. So amplitude would be that distance. It could also be that distance. Okay, so the red line would represent like a still pond, and then you throw a rock in it, and it disturbs the stillness of the pond. Okay, and how high those ripples are, that's your amplitude. How low that is, amplitude. The unit, it's a length. So we're measuring it in meters. Okay. The wavelength. This is the length or distance of one complete cycle. The length or distance of one complete cycle. The variable for this, you might recognize that from chemistry, is a lowercase lambda, which is an upside down inverted lowercase y. Okay. And this is the length for one complete cycle. So this is a wavelength. You could say this is a wavelength. You could say this is a wavelength. Length for one complete cycle. And it's also a distance or a length, so we're measuring that in meters as well. Good with that? Okay. Give this one a shot. Talk to your neighbor. Correct answer is educated elephants. What? Okay, so your wavelength could either be C to G, B to F, A to E. Okay, and your amplitude could either be I to H or I to C. Good with that? Okay. Like, okay, so is which one's which one's
It's the beat, because in the diagram that you did when you were putting the amplitude and the wavelength, you had that the wavelength was like where B to D is.
So here, so I had on here, it was here to here.
Oh, so that's my bad. Wait, what?
Yep. Nope.
I swear to God.
Nope.
Yeah, see, I'm not crazy. You put it. It was probably. You didn't put it all the way out.
I did the here to here.
You did that one. I got that.
Here to here.
I swear to God, you didn't put it all the way out.
Yeah. did. Okay. All right. Period. I think we've talked about this, defined this before in the past. This is the time it takes to complete one cycle. Time it takes to complete one cycle. Okay. The variable for period, capital T. The unit, seconds. Okay. Compared to frequency, this is how many cycles are completed in 1 second. Okay. The variable for frequency is a lowercase f, and the equation for that is 1 over t, 1 over the period, and that has units of cycles per second, which is a hertz, like the rental car company. H, capital H, Z. Okay, so frequency is the inverse of period in units of cycles per second. Okay, so we could say that period has units of seconds per cycle. Oops. Like the unit of cycles isn't really a unit, it's more of a counter, like 1, 2, 3. Okay, but you could, it's helpful to think of it as seconds per cycle. Good with that? Okay. Give this one a shot. Talk to your neighbor.
Oh, so just you just take the
Correct answer is? Correct answer is A. Okay. Period is seconds over cycles. Okay. Good with that?
Yep.
And the frequency is going to be what? Tell your neighbor. Correct answer is 4 cycles per second. Okay. There will be a question like this on the test. Statistically, a third of you will miss it. So, like, look to your right, look to your left. One of you will miss it. Don't be part of that third. Be part of the 2/3 that get it right. It's not a hard question. Just make sure you're on the 2/3 part. Okay? Cycles per second, frequency, seconds per cycle, period. Let's try that again. Another shot. Tell your neighbor.
Well, there's two of us thinking A, one of us thinking B, so this is the third.
It went over the period.
Also, at some point, you have to look.
I don't understand.
No, I'm thinking
This one.
Yeah.
I literally calculated what the period is, and then I put it under one.
Correct answer is.
I don't know.
Correct answer is A. Cycles. 12. Sorry. Cycles is 4 per second. 12. And what's the period?
Wait, what?
The period is 3 seconds per cycle. Don't miss this. It'd be really awesome if we get 100% right. Okay. When you were first introduced to the equation for speed, like in algebra class, like even before physics, speed is equal to what? What? What over what?
What?
Distance over time. Okay, right? Okay, dealing with a wave, what is the distance or length that deals with a wave? Wavelength. So that is the length for one, or distance for one complete cycle. What is the time for one complete cycle? That's what we measure. That's the unit, but what's the name? The period. So wavelength over the period gives us the speed of a wave. But we also know that frequency is equal to the inverse of the period. So this can also be found by saying the frequency times the wavelength. Good with that? All three of those are valid. Now, I'm going to try to make a connection with chemistry. I'm not going to hold my breath.
Please don't make me connect with him.
But some people might go, oh, so for the sake of those, when you're studying colors and like the color spectrum, you dealt with this equation. The speed of light is equal to frequency times wavelength.
What is that?
Don't worry about it. I'm just trying to make a connection. None.
Connection was lost.
None. None.
I knew the speed of it. I mean, I've heard the speed of it.
Okay. Go to that.
Yeah, we were supposed to learn the color spectrum. I don't know. We were supposed to, honestly. Wait, say that's crazy. Say so what's the yeah.
What?
What is? Is it just not like it's just we can use any of it?
Yeah. Any of those are the speed of the wave.
Oh, frequency times.
Yep.
I feel like I need to write that down. Speed of a wave. Okay, I got that. We're just.
Okay. Frequency.
That's confusing. With all the other
Yeah, but that was last semester.
But that's still my first. Surprising.
Okay. Give that one a shot. Tell your neighbor.
I'm not that stuff.
The thing is, I was about to get a cat on the and then when I saw the answer, yeah.
Isn't it me?
I don't like doing
I don't know why I didn't.
but basically,
Oh.
when we were from Malta,
I was trying to find the frequency
and
and
we were
Oh.
discussing
I knew it was a
before
I don't
class
know.
going,
Because that's the final equation I have written.
and he got so mad.
Correct answer is.
B. I got it.
Correct answer is B. 2 meters a second. Okay. It's wavelength divided by the period. The amplitude means nothing. Okay. You probably need a calculator on this one.
Alright. You go from numbers like 5 and 2, like 5 to 5 times 10 to the negative 4.
Right, and that, but I tell you, you need a calculator.
First and back. I don't even know what it is.
Also,
I feel like you're.
So like,
He doesn't want me to have
My calculator is still a
He
radio.
does not want me to have a car.
Taken from City Hall.
You can drive the smiling mobile.
like, if you want to get
Okay, wait. What was that?
and then like, let us have going to
I know, but
Wait, what article is there?
there's no safe way to explain it.
So you're gonna have to calculate the frequency on this one.
So also,
Wait, how do you do?
like, what is the reading and radiation?
I know.
Wait.
And I was telling her,
That's not going to
that's
wait.
not, it was manipulated.
No, you got this. You can't see sound waves.
2000 times. Wait, it's 2 times. But I tried that. Wait, but then what if you multiply it by like something? Wait, yeah. Because 1.45 cents.
Yeah. No, you do the frequency. Wait.
Have a conversation.
You are. You gave us big numbers.
You also have a calculator.
Okay. Well, I didn't get it right. Neither did I. I put 15.
I got 4 million. I did the frequency divided. Oh, that's way
But you
better.
can roll it.
Hang on.
I have 1450. But see, 1.45. So what if I just like divide it by? What if I?
He's like, you guys are so stupid. I got 14. Wait.
So what if? But what if you divided it by what was that, like 1,000 or something, and then you get 1.45? Okay, just
We got the right numbers. Not the right time.
Correct answer is
I'm gonna go B.
Because that's the closest I got.
correct answer is E. Educated elephants. What
Great.
what is the correct numeric answer?
1450.
1450.
Crazy.
So we were right.
Okay.
So we're set up.
So you could have done it wavelength over the period. You could have done it frequency times wavelength. Frequency times wavelength. Or you could have done it distance divided by time. Convert that to meters.
So basically, trust the guy.
That would probably
Now I see
All three of those gives you 1,450 meters per second. Good with that?
let's bring a breadboard
Oh.
computer.
But high times 2.
Okay,
Shout out to them.
good?
Yeah.
This has to be
We're chilling.
What was the answer?
all you do is
1,450, so E.
So as long as it doesn't get any better than this, we're good.
no frequency times
Time. Please.
Okay,
All right. I got you.
very good.
I'm ready.
Okay, there are
Maybe. Probably.
two different types of waves that we're going to look at in this class.
Oh, girl.
First is transverse. This is when, this is the first one. When the particles of the medium oscillate perpendicular to the way the wave travels. Oscillate means moves back and forth. Okay. When the particles of a medium oscillate perpendicular to the way the wave travels. It is a lot of words. And oscillate means moves back and forth. Okay. Which way is this wave, this animated wave, traveling?
Wait a minute. I don't know. That's really hard. But if you go to the other side, particles are going.
If you caught a wave, okay, it's traveling to the right. Everybody good with that? Okay, so find one particle and follow it. Follow the motion of one particle.
It just goes up and down. Yeah. Oh, it does.
To help you,
That does not help.
they were moving my eyes.
Wait, I don't understand what I'm supposed to be seeing. That's just not dog. So is it moving? No, it's just up and down.
It's moving. It's oscillating
Oscillating
up and down, perpendicular to the way the wave is traveling. It's a transverse wave.
Why can't the colors stay the same? What is the color change? It's cool effect. I know. It's hurting my eye.
Good?
Probably.
Struggle.
I
I
not want to go.
I am lucky you're here. All right. The next type is a longitudinal wave. Okay. So instead of the particles oscillating perpendicular, they're going to oscillate parallel. Longitudinal wave, when the particles of the medium oscillate parallel to the way the wave is traveling. Okay. Which way is this animated wave traveling? To the right. Okay. Good with that? It's kind of like looking at an ocean wave from a drone camera angle, like, okay. But if you look at one particle, just going back and forth, right and left, parallel the way the wave is traveling. Good with that? Try not to look at this three-dimensionally, like a carousel. Don't worry about it if you don't get it.
Oh, whoa.
Okay. So, longitudinal waves are sometimes known as compression waves. So this would be a longitudinal on a slinky. Okay. So that would be a longitudinal wave. You know that? Okay. So there are certain parts of a longitudinal wave. This is known as compression here. This point, this point, this point, compression. Not too hard to understand why. Okay. Places that are not compressed, the spread apart parts, are known as rarefaction. So like here, 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 those are rarefaction. Okay. To draw a longitudinal wave is kind of a pain. A lot of dots. So often what we'll do, like a sound wave is one example of a longitudinal wave. We will illustrate a longitudinal wave like a transverse wave because we're going to graph the pressure. Okay, so this would be normal pressure. At the compression, that's where you have high pressure, and the rarefaction, that's when you have low pressure. So they'll draw it as a pressure graph High pressure, low pressure, high pressure, low pressure, high pressure, low pressure. Instead of drawing it like that. So that's hard to draw. Cool with that? Close. Okay.
Oh, excuse me.
Okay. So here's a longitudinal. This is where I stole this animation from. Here you can see the red dot, and they have compression and rarefaction labeled here. Okay. This would be a transverse wave. So a common question is, well, what is an ocean wave? Turns out an ocean wave is a combination of transverse and longitudinal. If you think of like a seagull or a buoy or a piece of driftwood, it does this motion. So it's moving not only up and down, but also left and right. If you've ever snorkeled before in like really shallow water, it's like, whoa, whoa, whoa. No, like you're like not only getting closer to it, but you're also being brought forward and back. But that effect diminishes as you get deeper. Cool with that? You got a pre-quiz due tomorrow.